Top tech firms often use coding challenges to assess a candidate's problem solving skills, coding proficiency, and understanding of algorithms and data structures. In this particular video series, we are going to look at some of the common types of coding challenges used in interviews at top tech firms like Google, Amazon, Facebook, Microsoft, and we will solve it. We'll be using JavaScript in this particular example because it's much easier to use that, but you can kind of translate that into any other programming language very easily if you just understand the logic. The first one that we're going to look at is array and string manipulation, where we're going to look at how to reverse a string, find the longest substring without repeating characters, and merge two sorted arrays. These are the most common ones in array and string manipulation. Next, we're going to look at linked list, where we'll detect a cycle in a linked list, find the end node from the end of the linked list, and reverse the linked list. Now, if you're not familiar with these, as and when we solve these problems, I'm gonna explain it to you what they are. Next, we're going to look at trees and graphs, where we are going to implement tree traversals, where in order, pre-order, and post-order types. We're going to look at a lowest common ancestor in a binary tree, and we're going to detect a cycle in a graph. Sorting and searching, one of the most common ones that always is used just to check your algorithmic experience. In this particular case, we're going to look at implement quicksort or mergesort. We're going to look at binary search in a sorted array. We're going to find the kth largest element in an unsorted array. Next, we're going to look at dynamic programming, where we'll try to solve the knapsack problem. We're going to look at the longest common subsequence, and we're going to look at longest increasing subsequence. Then we're going to look at recursion and backtracking. Solve the n queens problem. We'll generate all the subsets of a set, and we'll also do a Sudoku solver just for the fun of it. Another common thing is bit manipulation, where we can count the number of set bits in an integer. We can find the single non-repeated element in an array where every other element appears twice. And finally, we're going to look at swap two numbers without using a temporary variable. That's kind of interesting, one of my favorites. Next, we're going to look at hashing, where we're going to look at find the first non-repeating character in a string. We do some check if two strings are anagrams, and finally we're going to look at the two sum problem. Again, if you're not familiar with these and you are stuck in between, you can just Google it before we go into solving these problems. There's also stacks and queues, where we're going to implement a queue using two stacks. We are going to evaluate a postfix expression. We'll design a stack that supports push, pop, and retrieving the minimum element in constant time. Next, we're going to look at some mathematical problems. Check if number is prime, generate prime numbers using the Sieve of Eratosthenes, find the greatest common divisor, which is GCD of two numbers. These are the 10 different sections that we'll be covering in detail in this particular video series, so stay tuned. So let's start with our first problem, which is array and string manipulation, where we're going to reverse a string. For this particular series, I'm going to use Replit, which is REPL, which stands for read, evaluate, print, loop. .it, that's used to be the website before, but now it's replit.com, and I've used a Node.js application in this case, but I'm just going to write JavaScript, and I can run this JavaScript on the right side. If you're not familiar with this, whatever JavaScript you write here gets printed on the right side. So I can delete this and then print and start from scratch. Now the first one that we will be looking at, which is the reverse string, there is one built-in method. Now this is actually cheating. They will say that don't use a built-in method for any of the programming coding challenges that you, but why not? Let's see. So I'm going to use function reverse string and pass the string to this. And in this particular case, I'm going to say return string dot. So I'm going to take the string that is provided to me. I'm going to split it. This is the one best part about Replit. It will try to give you solutions right in on the screen. So I'm going to split the string. So let's say it's hello, HELLO. So it will split into an array. And then I'll reverse the array, calling the reverse function of the array. And then I will join them again. Join function will take all the elements inside an array and join them back. So let's run one. console.log. Okay, there you go. It kind of listens to me, I feel. And there you go, reverse a string. Easy as that. I can just say something else, Vivian run, and now it has reversed the string. This is a very simple way of doing it, but of course this is, I consider it as cheating. I would never ask anyone to use the built-in functions. Next is using a for loop. So what we do in a loop is we iterate over the string from the end to the beginning and build the reverse string one character at a time. That is another way of doing it. So I'm going to write that one function reverse string, pass the string to it, and in this case, as I mentioned, I'm not gonna use use the built-in function. So let's create let reversed equal to, so I'm going to create a string, empty string, and then I am going to for let I equal to string dot length. I think it already knows based on my function name what I'm going to do here. So I'm going to go create an I, which is string dot length, which is the length of the string minus 1, because I'm going to go from end of the string to the first object, which is 0, greater than equal to 0, I plus plus. In this case, I'm going to say reverse string is this string, return reversed. So this will give me back the reverse string console.log, and inside that, come on, give me the, okay, there you go, reverse string hello, run it, and we have the same output as before, just that this is not capital. Vivian, run it, it should give me same. I'm going to clear it out. So that kind of shows us the second method, which is the loop. I'm going to use another one, which is recursion. Now what we're going to do now is recursively call the function with the substring excluding the first character and append the first character to the result. So that's how we can use recursion here. Keep my function reverse string, and I'm going to say if string equal to empty, then I don't have to do anything. I'm going to return empty. Else return reverse string. I'm just calling the same function again recursively, string dot substring of 1 plus string dot character at 0. So what this does is it will call this function again and again with this particular string. So first what I'm going to do is, let me just go ahead and so I can explain it step by step. Reverse string hello. So in this case I'm passing this thing to this guy and it's not empty. So what it's going to do is it's going to return back reverse string. It's going to pass the first element and the string substring at 1, so E and 0. So it's going to switch them and pass that back, and it will keep on like it will call the substring from 1, which is right here, pass ELLO plus H adding to the end, and it's going to keep on calling that. So it will create my reverse string using that method. So it passes LO plus H, then it goes here, and then again it will pass LLO plus H, and it keeps on going through this loop recursively, this function recursively, and create this reverse string. I'm going to do one more thing, which is the array reduction. Now inside array reduction you can use the reduce method to accumulate the characters in the reverse order. So that works something like this. I'm going to keep this here, and I'm going to say return string dot split reverse. Nope, I am not going to use reverse this time. I'm going to split the entire thing, then use the reduce function, and inside there I'm going to pass the reverse and the character, and I'm going to say character plus reverse in this particular case. So this kind of gives me that element out. Close this. Guess there's no errors, so reduce to, okay, perfect, and call this, run it. There you go, you have your reverse string here. Run again. Yep, there you go. So this array reduction is much more easier, but again it's using the reduce function that is available. So this is our first solution of creating reverse string. Let's go to the next one. The next problem in the array and string manipulation is the find the longest substring without repeating characters. For example, if I have a substring for something like ABC, ABC, BB, in this case the longest substring without being repeated is ABC, which is of length 3. So that's what we need to find out in this particular problem. Now, finding the longest substring without repeating character is a common problem that can be solved using the sliding window technique. However, here's how you can solve it in JavaScript. So I'm going to use REPL again, replit, and I'm going to write length of longest substring. Thanks to this coding coding tool, it knows what I'm trying to do. So first, what I'm going to do is I'm going to get the length of the input string s. So for that, I am going to create n equal to s dot length. What I'm going to do next, let me see if I can increase the size of this. Maybe it's good. Okay, s dot length. Next, I'm going to create a set, a variable set, which is a set that will store characters currently in a substring. Now, set is a special in JavaScript or any programming language which will have only unique characters inside it. Then I am going to say max length equal to 0. Now max length keeps track of the maximum and will also maximum length of the substring found so far. So it will keep on updating that depending on what we get. Next, we can also create I equal to 0 and j equal to 0. Now these I equal to 0 and j equal to 0 are the 2 pointers defining the current window I comma j. So that's what these are. Now I'm going to write a while loop where while is here. Using a while loop will iterate through the string with the pointers I and j, and we'll run this through continue this process until j reaches the end of the string. So once I start there, let me just add my bracket, and let's try to extend the range by saying if. So what I'm going to do right now is I'm going to check if the character s of j is not in the set, and if it's not in the set, I will add it to the set, move j to the right, and update the max length. So to do that, I'm going to say if not set dot has s of j, I'm going to say set dot add. Come on, complete it for me. I got lazy by it auto completing s of j, so I'm going to add that. I'm going to increment j by 1, and then I'm going to also increment max length to mat.max, max length of j minus I. So now what if the character s of j is already in the set? Then we'll remove the character s of I from the set and move it to the right. So else I'm going to say set dot delete s of I and then increment I plus plus in this case. So this will continue until the process will continue until j reaches the end of the string, and we'll have our max length here. Return max length. So the variable max length will contain the length of the longest substring without the repeating characters. That's what we are returning back. So let's play it out. Console.log, and inside this I am going to give a string of this. It knows exactly what I want. Run it, and it will say 3. If I do d here, run it, and if you see ABCD is the longest. If I remove this from here and do here, run, it will say 5 ABCDE. So that's the 5 length string, and that kind of shows how you can do the find the longest substring without repeating character using JavaScript. The next problem in array and string manipulation, and also the last one that we're going to look at, is merge two sorted arrays. Now in this particular case, we have two arrays which are sorted. So for example, if I have first one 1 2 3 let's not 1 3 5 7, this is I said 3 but I entered 3, and another array which is 2 4 6 and 8. What I want to do in this particular case is I want to sort both these arrays into a third array, which is 1 2 3 4 5 6 7 8. So kind of sort them in an array. So for this particular problem, what we are going to use is something called as the two pointer technique. Using two pointer technique, you have 2 pointers for each and every array, and then you compare them and you merge them into the third array. Let's look at the solution, how to go ahead and do this. I'm going to call it function merge sorted arrays, and this will take two arrays as input, array 1 and array 2. First we're going to create a merged array which is an empty. Oh, it kind of wrote me the entire program here, but we can probably look at it. So yeah, this is what I'm going to do. Merged array, make it empty. Then I'm going to create I and j, which are the 2 pointers for array 1 and array 2 respectively. And then I need to get, let me just remove this because my technique is a little bit different. So I and also I like to initiate things together, and then I'm going to create n and m element constants which are, sorry, variables which are lengths of array 1 and array 2. So I'm going to say n equal to array 1 dot length gth, and then I'll create m which is array 2 dot length. So this will contain my lengths of the array. Now I'm going to write a while loop where so the two pointer technique, what it does is, first it uses a while loop to iterate through both arrays simultaneously, compare the current elements of both arrays, in this case array 1 and array 2, and push the smaller element into the merged array and move the corresponding pointer I or j to the next position, and repeat until one of the array is fully traversed. So that's what we are going to do. So I'm going to say I is less than n and j is less than m. I want to, in this case, check if array 1 of I element is less than array 2 of j. If it is smaller, what I'm going to do is I'm going to push it into the merged array dot push. I'm going to push array 1 of I. If not, okay, I'll also make sure that I plus plus. If not, I am going to say merged array dot push. In this case, I'm going to push array, because array 2 is smaller, of j, and then I'll increment j plus plus. Once that is done, now after this there might be a condition where there are some remaining elements in array 1. So after the loop, what I'm going to do is, if there are any remaining elements in array 1, I'll push them into the merged array. So while I is less than n, I am going to say merged array dot push array 1 dot I, and then increment I plus plus. So this will do that. Same thing for array 2, because what if like array 2 has some elements left? There's either one or the other, because one of them will probably be completely traversed. Push array 2 of j, in this case let's say j plus plus. So that should take care of it. And now this, I can return the merged array in this particular case. Looks good. Let's try it. So if I create first array of, okay, so the one that I mentioned earlier, let's see if it creates the second one too, equal to, there you go, second array. And now I'm going to say console.log the merged array, which is merge sorted arrays, and I want to pass array 1 and array 2 in this particular case. Run this, and we have 1 2 3 4 5 6 7 8 9. I can always try to see what happens in this case. Run it, and you'll see 1 2 3 4 6 7 8 9 10. So if you see, it still managed to give me the right answer. So yeah, so this is the solution for merging two sorted arrays in JavaScript. Next topic is linked list. Now detecting a cycle in a linked list is a classic problem that can be solved using Floyd's cycle finding algorithm, also known as the tortoise and hare algorithm. Let's see how to implement it in JavaScript. First, let's define the structure of a linked list node. So I'm going to use classes for this, and I'm going to say class list node, and this one has a constructor with value and pass, and that this dot value, I'm going to set that to value that is passed, and I'm going to say this dot next, so the linked list's next value, set it to null for now. So this is my structure of the linked list node. Now the Floyd cycle algorithm, as I mentioned, we use two pointers in that: a slow pointer, which is called as the tortoise, and the fast pointer, which is called as the hare. The slow pointer moves one step at a time, while the fast pointer moves two steps at a time. If there is a cycle, the two pointers will eventually meet. So for that reason, let's go and say, let's create a function where we can check if it has a cycle, and we'll pass the head to it, and inside that I'm going to check if head is not there or not head dot next. Then I don't need to do anything, and I'll say return false. That means there's no cycle because there's no head or no next head next. Next, let's create the pointer. So slow equal to slow pointer, I'm going to set it to head, and to start off with I'm also going to set the fast to the head. So next I'll say while, so now this is where I am gonna create the loop where saying fast is not equal to null, and I need the fast dot next is not equal to null. In this case I'm gonna say slow equal to slow dot next, and fast equal to, since I'm going to do 2 pointers ahead, it will be fast dot next dot next. So that's good. And then next here I'm going to check if slow equal to fast, if both are same, which means there's a cyclic. So I'm going to say return true. So that's how you can set this thing. And then at the end, if the entire function runs and it didn't reach to the return for true, I'm going to return the false. Now let's create a example in this case. So I'm going to create a linked list which is 1 points to 2 points to 3 points to, I don't want so many. Let's create the actual notation. Don't like to go into details, but yeah, this is the linked list that we have. So I'm going to create this, and I am going to say constant head equal to new list node and pass it the value 1. Next I'm going to say head dot next equal to new list node and pass the value 2. Head dot next equal to 3. Now again dot next equal to 4, and then 5 is one more dot next. So this is my, now let's see if it has a cycle. Console dot check log has cycle, and I'm going to pass the head to it. In this case there is no cycle, so it's not gonna cause any problem, but I can also do here next and create dot next, and this time I'm gonna assign 5 to 2, which means I'm creating a cycle where 5 is pointing to 2. In this case, let's see, what does it say here? Run it, and it's a false and false. Okay, this is something. Head dot 1 next. Oh, it's I can't create a new node. If I create a new node is 5 and 2, I am going to say that is attached to head dot next. sorry, so 5 is now head dot next is 2, so I'm assigning it this next node to that. So run this, false and true. So that's how we can create using the Floyd's or tortoise and hare or Floyd cycle finding algorithm. We can solve this problem to detect a cycle in a linked list. Let's go to the next one. The next problem that we have is the finding the nth node from the end of the linked list. Now that can be done efficiently solved by using the pointer technique, where the two pointer technique says that we can create 2 pointers where the first pointer is advanced n nodes ahead of the second pointer. When the first pointer reaches the end of the list, the second pointer will be at the nth node from the end. So it's pretty simple, straightforward. So let's create first the linked list class list node, and this node has constructor value and this dot value equal to value, and then I'll say this dot next equal to null. So our default linked list class. And now for the 2 pointer technique, I'm going to create a function called as function, and I'll say find nth node from the end. I'll pass head and n, that's perfect. And in here first let's create the first pointer which points to head, and let's create the second pointer which points to head for now, and then we'll move the first pointer n steps ahead. So I'm going to say for let I equal to 0, I is less than n, I plus plus, perfect. I am going to say if first equal to null, then I can just return null. So in this case, if n is greater than the length of the list, we're just going to return null in this case. If not, I am going to say first equal to first dot next. Now we have to move both pointers until the first reaches the end. So once the pointers have been allocated here, now I'm going to say while first is not equal to null, I am going to move first to first dot next, and I'm going to move second to second dot next and at the end I'll return the second, which is the nth element from the nth node, nth element from the where the nth item. So there you go. This should solve our problem. Let's look at an example usage. So let's say same example we have 1 pointing to 2 pointing to 3 until s2 until 5. So we link list. Now I'm going to say constant head equal to new list node 1 head dot next equal to new list node 2. Just copy this one dot next in this case is 3. In this case it's 4, which is dot next, and then dot next is 5. So we created these 5. Now find the in this case what we'll do is we'll find the second node from the end. So I'm going to say constant nth node is find nth node from the head 2. So let's see console dot log, let's log it out. I'm going to say nth node is what I want to, if it exists then I want to print nth node dot value, or I can just say not found in this case, or null, whichever. I'll run this, it's just 4. So second node from the second end item is 4. Perfect. So that's what we have. What if we want to find, let's say nth node 2. This time I'm going to find the node which is 5th. Okay, and then I'm going to do the same thing. Let's keep them together. 2 dot find run, and that will give me 1 because the 5th node from the nth node, which is from here, is 1 2 3 4 5 is 1 again. So that output looks fine. Now what if I want to find the 6th node? I want to find the 6th node, node 6. Run it. I should say not found because that doesn't exist. 6th node from the head, like from the end of this, it is 1, this is 4, so it's perfect. So these are working perfectly, but not the 6th node because there is not 6th node in there. So that kind of concludes our find the nth node from the end of a linked list. So let's jump to the next one now. Now let's look at the reverse linked list. Now I've kept the linked list from our previous examples as it is, and also added a reverse linked list function here, but I've kept all the basic parameters in there, so I don't have to type it again. Now reversing a linked list is a common problem that can be solved iteratively or recursively. Let's implement let's see how we can do this in JavaScript. So first, our node is there, list node is there, this looks good. Next, let's look at the iterative solution. So I'm going to say find reverse linked list, pass the head to it, and let's say let's get the previous item, previous equal to null, and current equal to head. So let's take this. Now I'm going to do, as I mentioned, iteratively. So I'm going to run a while loop on current is not equal to null. What I'm going to do here is I'm going to get the next one, store the next. So first I'll store the next node in next variable, current dot next, and then I'm going to reverse the current node's pointer by saying current dot next equal to previous. Then I will move the previous pointer to the current node. So I say previous equal to current, and finally I'm going to move to the next node, and current equal to next, and then I will here return the previous. So this will reverse our linked list using the iterative solution. Now another solution is using a recursive solution. You can write something similar, and this time I'll say recursive, and inside here I'm going to check first if head equal to null or head not equal to null, then return head, and then it wrote everything for me. So I'm saying that new head is called this function again, since it's a recursive solution where reverse linked list recursive head dot next is what I pass, and head dot next equal to head dot next equal to null, and return new head. So this will solve our problem for reversing a linked list using a recursive strategy. Now let's kind of check if these work. I'm gonna delete this console, clear the console, and since I've already created the linked list, I am going to first say constant reverse head equal to reverse linked list. I'm going to call that one first. I'll pass the head, and I'll say uh, console.log reverse head. Let's run this. Oh, and it's gonna print me the nodes in this way: 5, then next has 4 3 2 1. If you want to print it in a proper way, I can also write a function for that to see. I can call it print linked list, and this function print linked list takes the head. This, let's make sure that I didn't do a typo over there, and then here I'll say let current equal to head, let result equal to an empty array, but we'll do up so you can see it properly. While current is not equal to null, I want to add into result the current dot value, and next I'm gonna say current equal to current dot next. Set that up, and once that is set, I'm gonna say console dot log result. I'm gonna say join and join by, since we're using arrow, I'll do that, and let's run this. There you go, 5 4 3 2 1. If I want to use the other one, which is the recursive reverse linked list recursive, run it. It will give me the same solution, because of course there are two different ways of doing the same thing, one iteratively, one using recursion. So that kind of completes our linked list solution. Let's move to the next one. Tree traversals are fundamental operations in tree data structures. Here's how you can implement. Here we're going to implement the in-order, pre-order, and post-order traversals in JavaScript. But first, let's see how our tree is structured. So for example, let's say class tree node. I'm going to create a class for this, and inside this I'll create the constructor which will have a value, and based on that this will have this dot value equal to value, and then my tree will have left and right nodes. So this dot left equal to null, and this dot right equal to null. So this is, so every tree will have like two branches, left branch and right branch. Now for example, if we have a tree with the tree nodes, for example in this case, let's say we have one is the parent root node, then under that we have 2, and we have, let's say, 3, and under 2 I have 4 and 5, whereas under 3 I have 6 and 7. So the root node is 1, below that is 2, and below that is 3. So I'm going to just make it like this so it's much more clear. So this is the center, 1 2 4 5 6 3 and 6 and 7. So now there's 3 type of different traversal that we'll do: in order, pre-order, and post-order order. Now for in order is going from the left. So for example, here the in order works in this way. If the output of in order will be 4, then it goes up because parent is 2, and then it checks if it has any more children on the right side. 5 it does, and if it doesn't have anything, it's going to go up, which is 1, and then it's going to look if it has kids and go all the way to the left of it, which is 6, and then 3, and then 7. That will be our output. So our in order output for this particular case should be 4 go up, 2 go 5. I think this one actually understood what I'm trying to do. This is our in order. Now for the next one, which is the pre-order, the output will be, output start from the top, 1, then it goes 2, and then it goes to the left one, which is 4, and then from there it will go up again because there's no more, so it's going to go down again, 5, and then it's going to go up 3 6 and then 7. So that goes something like this: 1 comma 2 comma 4 5 3 6 7. Yep, that's, thought I got it there. 1 2 4 5 3 6 7. That's our pre-order traversal. And the post-order traversal is starts from the post-order traversal is interesting, where it start from at the bottom 4. It's going to see who the parent is 2, and then see how many kids that is have. So it says 4 comma 5, and then since it doesn't have any more kids, it's going to go up, or leaves, it's going to go up to 2, and then it will go again 1, and 1 has a bunch of more, so it's going to go 3 and then 6 7. So it will go to 6, then 7, then 7, and then 3 and 1. So this is how we will be doing the first one is in order, the second one is pre-order, and the I hate it when it doesn't align properly, and the last one is the post order. So these are the three traversals that we'll have to implement in JavaScript. So for this, let's start with our function for in-order traversal. So for, no, I don't want to, in-order traversal. Now for in-order, the first thing that I need to, let's write a function. I'll call it in-order traversal, and it will get not the root, it will get the node element, and the result will be empty array. Now what I'm going to check here is, first I'm going to check if node is not equal to null. If node is not equal to null, I'm going to recursively call this in order traversal and pass it node dot left and the result with it. And I will make, after that I will make result dot push, and inside that push I'm going to say node dot value. And in next, after this, I'm going to call the in order again to do the right one, node dot right, and pass the result to it. So that's how you can do, and then the result is the in order array. Same thing for the next one. Let's do all three of them, and then we can run, or let's run it first, and then we can check the values. I'm going to say constant. I'm going to create root equal to, so I want to create this tree here that I have. I'm going to say new tree node with 1. Root will have a left node. If you look at this structure here, I want to say new tree node and pass it the value 2. I'm going to create right, and then right will have the value 3. Now because this is also a tree node, so root dot left, okay, that's good. It already knew what I wanted. Next I want root dot left dot right, which is this, perfect. Next I want root dot right dot left, which is 6, perfect. And then I want root dot right, which is 7, perfect. So it has a very good smart engine which does pre-filling automatically. And I'm going to say here in order traversal, this case, comma, and call the in order traversal function and pass the root to it. Let's see what is the output. And there you go, 4251. Let's compare it with the 4251637. Perfect. So that was the array that we were expecting. So let's keep this here. And next, let's do the next one is pre-order. So let's do pre-order function. Let's see if it automatically writes the code for me, so I don't have to worry about it. In pre-order, I have the root, again same thing. In this particular case, I am going to say if node again is not equal to null. If it's null, then I will return, at the end I'll return the result. If node is not equal to null, I'm going to say result dot push. So in this case, I'll push the node value first, because as you know, we're going to go from the root at the bottom, so it goes to the 1 is the first element. Then I'll say pre-order traversal, I'll give node dot left and result, and then I will do the pre-order traversal node dot right. Come on, fill it up. Nope, doesn't want. Sometimes I'll write the code result. So if I run this again now for the pre-order, let's see how does it look like. Run, and there you go, 1 2 4. Let's compare it. 1 2 4 5 3 6 7. Perfect. And finally, let's go write the function for post order. I'll make sure post order function is gonna write it for me. Oh, I think it did. Past order traversal. Okay, there you go. That's my function, and inside my function, I'm gonna say again if node is not equal to null, I am going to say, so in this case, post order traversal first starts with left node dot left and pass the result. Then I'm going to pass the post. I think messed up here. So it's post order traversal. Then I'm going to do the right. Comma result. And then finally, I'm going to say result dot push node dot value. And I will pass the result back here. So now let's run this one. This is post order traversal, run it. And if you see, compare our results 4526731, perfect. So all the three traversals were done successfully. So this is the code for that. If you have any questions, let me know in the comments and we'll jump on to the next one now. Finding the lowest common ancestor LCA in a binary tree is a classic problem. Let's see how we can solve this in JavaScript. So first, let's create our tree node definition, which we need anyway. So class tree node, and that I will create by calling the constructor, and the constructor will have some value to it, which I will assign to this dot value equal to value. There you go. Left is null, right is null. So that kind of creates my tree node definition. Next, for finding the lowest common ancestor, the LCA of, let's say, two nodes P and Q in a binary tree is defined as the lowest node that has both P and Q as descendants, where we allow a node to be descendant of itself. So let's look at the implementation. So first, I'm going to write a function called as lowest common ancestor. Now root P and Q, these are the common terms that I used, so that's why it automatically filled it up. If root equal to null, I'm going to return null in this case. If root dot, so in this case I'm going to take this for now, but I'm going to say if root equal to P or root equal to Q, then I'm going to return the root. If left, okay, then I have to check for, so in this case I'm going to say const, so let's not do constant, let's do let left equal to lowest common denominator root dot left P and Q, and let right equal to lowest common denominator com right dot perfect. So we pass that thing and call them and get the left and right. Now if left is not equal to not equal to null, and right is not equal to null, then in this case we will return the root. That will be the solution for this. If not, then what I'm going to do is I'm going to say return left not equal to null, then I'll pass left or else I'll pass right. So that's how you can find the lowest common ancestor in a binary tree. Now let's run this and see if it actually works. So first I'm going to create a root new tree node of, let's say, 3. Then I'll say root dot left equal to, I'll assign the value 5, because if you remember from our tree structure, this is how the numbers are, like the left root has for 3 is 5. Then for the right of 3, we have new tree node, use 1 for this, and then for root dot left of left, I will assign it the value of 6. For root left right, I will assign this value of 2. Now next I would want to do the, so I did root left right, now root right of left, root right of left has a value of 0, root right of right has the value of, let's say in this case, 8. Let's make one more. Root dot left dot right dot left has a value of 7, and then root dot left dot right dot right has a value of, tree node has a value of 4. So this will look like, so if I want to draw it out, 3 will be on the top and it will have left will be 5 and the right will be 1. Next I have left of left, which is 5, is 6, and left of right will be 2, 2, and then right of left will be 0, and next is 8. So this one has these two, and then I have also created after that the left of right left is 7 and then 4. Oh, not this is not right, please. 4, please work with me. And 2 doesn't have anything, 1 has these two. Just move it so it doesn't make any. Okay, so that's the entire true node. Now for nodes for which we want to find the LCA, let's go ahead and say constant p equal to root dot left and constant q equal to, I'm going to look for root dot left dot right dot right. Now its value is, node value is 4 here, node value is 5 here. So because 4, because here left dot right is 4 and it's 5. So I'm going to say if I want to find the LCA, lowest common ancestor, root p and q. So that's what I'm going to pass. Let's see console.log, move it up so we can see better. So .log LCA.value, let's run it. So 5 and 4, let's see what do we get. In this case we'll get 5 because 5 has the, so in this case 5 has the lowest common ancestor. So this is the solution for finding the lowest common ancestor in a binary tree. If you have any questions, let me know in the comments. Thank you. Detecting a cycle in a graph can be done using the depth first search. But there's two types of graphs that we have. We have the directed graph and undirected graphs. Now, what is the difference between them? The directed graph, in a directed graph, the edges have a direction. Each edge is represented as an ordered pair of vertices where u and v, where the edge goes from one vertex, which is u, to vertex v. Whereas in undirected graph, the edges do not have a direction. Just from the name you can say that. But each edge is represented as an unordered pair of vertices, uv, indicating a two-way relationship between the vertices. So that's how so the directed graph have a direction, whereas uh, undirected graphs do not have a direction. So let's see how we can implement for detecting a cycle in a graph. In first, let's look at the undirected graph. So first, let's create the graph. I'm going to say graph equal to constructor vertices, and then in this I am going to say this dot vertices equal to whatever vertices is passed to me. I'll pass it here, and then this dot adjacent list equal to new map. Whatever is adjacent to it is in a new map. That's our constructor. I'm going to do add vertex first of all, and which gets v. This dot add, so this is perfect. So that's adding a vertex, and now let's add edge to the v comma w. As I mentioned, these are the standards, and so this dot adjacent list dot get v. In this case, I'm gonna push to this w, and start get w. I'm gonna push v to it. So undirected graph. That's why. So that we have it. Our graph is ready. Next, let's write the function inside this itself, the class itself. So I'm gonna say detect cycle is the method that I'm gonna use, and inside this, first I am gonna say if I have a visited versus parent visited node equal to new array, and inside this I'm gonna add this dot vertices and this dot vertices and fill them to false. So I don't want to fill them up right now. Set them to false. Then I'm gonna do the parent. In this case, I'm gonna say new array. This dot vertices fill is not null but -1. Now let's write a for loop where I'm gonna let I equal to 0 go through the vertices and I plus plus perfect. And inside this, I am gonna check if not visited I, then it wrote the entire thing. If this dot dfs, which is dysfunction or dfs cycle detection, directional cycle detection, I like to use the full name detection. I visited parent, return true. Now I have not even written this function, it knows that I'm going to write this function. Very smart. And in here, wherever this ends, I'm going to run that function which has v visited and parent. Inside this, I'm going to say visited of v is true. I set that to true because that is what is passed here. Next, I'm going to say for let I equal to 0, I is less than get v length plus plus. I am going to say in this particular case, if I actually I want to do for each in this particular case, but I guess this also works fine. If I think it had the code ready for me, but let me write it. If not visited, then of visited of I, then in this case I will say parent is parent of I equal to v. Looks right. And then I'm going to say if this dot the function I dot visited, then return true. For the previous one, I'm going to say else if I is not equal to parent of v, then I'll say in this case it will return true. And if none of this works, then after this I'll say return false here, and that should take care of that. Now let's run an example of this and see if this works. This one was for undirected graph. That's why we had to create the multi-direction. I'm going to create a graph here. It knows that I want to create a graph of for g dot add vertex. I'm going to say 0. I am going to add 3 more vertices, 1 2 3 4. So I'm going to say 1 2 and 3. So I added those vertices, and I'm going to g edge 0 1. Come on, write the rest. Add edge 1 comma, so I'm going to create the edges here 1 2. I'm going to say g dot add edge to 0. So 1 1 0 1 1 2 2 0, and next one I'll say g dot add edge. In this case I'll add 2 comma 3. Now this I should detect a cycle in this case, because if you look at it, the graphs are in this particular 0 1 1 2 2 0, so that's why there's a cycle in there. So I am going to say console dot log g dot detect cycle, and that's it, because I pass the entire object. And it says true because there is a cycle in there. Now next, for the directed graph, let's do the directed graph. Let's try to modify this one itself to do a directed graph. This dot vertices, add vertex, set. This is fine. VW dot add edge. Okay, this one here, since it's only one directional, I am gonna say v dot push w. Rest of the stuff will stay same, so looks good. Now to detect the cycle, visited equal to new array, this dot vertices fill false, and then instead of this, I'm gonna say rec stack. Since it's not a undirected, it's a directed one, I'm gonna create this, and here I'm gonna say fill as false for this two. Let I is equal to 0, I is less this dot vertex, I plus this, and in this case don't have to check this. I will say if for let I is equal to 0, I plus plus, I will say if this dot cycle function I visited parent return true, else I'll do return false. There you go. I think I removed, did I remove all the, let's make sure that this is properly formatted. Return false, and there you go. This looks good right now. And then for my cycle detection, visited in this particular case, let's change this, and I'm going to say if rec stack, in this case rec stack of v, then if this is true, then it's return true. So this has a cyclic behavior, cycle detection. Next I'm going to say if visited equal to v, visited v is true, then I'll say return false. It doesn't have cycle. Next case is, let's say visited of, if none of the above qualify, then I'm going to say visited v is false and rec stack equal to true. So both of them I'll set to true, and then I'll run my for loop for let I of this dot list dot get v. In this case I'll say if this dot, so I'm going to check if the DFS cycle detection passed the values I, visited, and the rec stack, and in this particular case, close this, if close all the properly, okay, return true. And the next one that I have to do is to this bracket here, I'll have to say rec stack, thought it was rec stack of v, I'll set it to false and then return false. So that kind of detects our cycle. I'm going to clear this out here, and in here let's see our graph 4 0 1 2 3 g dot h 0 1 1 2 2 0 3, I'll just say 3 comma 1, and let's see if it detects the cycle that we've created here. It says error on the parent, which should be rec stack, run it on line number 24. Oh, I have to pass the rec stack. There you go, run, and there you go. It shows, it detects the cycle and it says true. So this kind of worked perfectly for both undirected and directed graphs, and this is the solution for detecting a cycle in a graph. One of my favorite is sorting and searching questions. Now, one of the couple of the algorithms that I used are quicksort and mergesort for sorting. Now, these are two fundamental sorting algorithms commonly used due to their efficiency and simplicity. Let's go over quicksort first. So quicksort is a divide and conquer algorithm that works by selecting a pivot element from the array and partitioning the other elements into two subarrays according to whether they are less than or greater than the pivot. The subarrays are then sorted recursively. So that gives you the sort. So first let's go ahead and say function quick sort, pass the array, and then first I'll check if array dot length is less than equal to 1, which means there's only one element or no elements inside it. So then I can just say, okay, return the array, which means the array is already sorted since there's only one element or no elements at all. Next, I'm going to start with the pivot point. So let's say, let's pivot equal to array, and inside that I'm going to say math dot floor array dot length. So I'm going to divide this array by 2. So that should give me the pivot point, and I'll create two arrays. Let left equal to empty array and let right equal to another empty array. So that gives me the 2 and the pivot. So now next I'm going to say, I'm going to go through each and every element in the array, and I am going to say if I is equal to math dot floor of array dot length divide by 2, then in this case I'll continue. I don't want to do anything else. That's good. But if array of I is less than pivot, then in this case I'll say left. I'm going to put that object in the left array of I. Else, of course, I'm going to put it in the right array. So this is how you can do divide and roll, divide and sort array of I. Once I have these, next I can just return with quicksort, pass the left dot concatenate pivot and quicksort the right. So we're going to go over this recursively and call this function and get my sorted array. Let's see an example. In this case, I am going to create, let's move it up, constant array to sort, and in this case let's give it number 3, 6, 8. They're already sorted, looks like 10, 1, 2, 1. Okay, perfect. Next I'm going to say console.log, and now I'm going to call that quicksort array to sort. Run this, and there you go, 1, 1, 2, 3, 6, 8, 9, 6, 8, 10. So that's my sorted array using quicksort. Now next, look at the merge sort. I'm going to get rid of this, and I'm going to create a new one called as function merge. So with merge sort is another divide and conquer algorithm. It divides the array into two halves, recursively sorts each half, and then merges the two sorted halves to produce the sorted array. So let's do that. Function, I'm going to create a merge function for left and right, and inside this I'm going to say let result is an empty array, and I'll create the left index equal to 0. I'm going to create the right index equal to 0. Once I have these indexes, I am going to write a while loop where left index is less than left dot length and right index is less than right dot length. Perfect. What do I want to do? If left of left index is less than right of right index, in that case what I want to do is I want to push the element in the the left element in my from my left index into result array, and then I'll increment the left index. So that's increment, Else the other way around, I am going to put it in the put in result the right with the right index and increment the right index after this. Once I have this here, I am going to return the result dot concat and recursively call left dot slice left index con and then at the end concatenate right dot slice right index. So that's my result. Okay, perfect. So next I'm going to write the function to merge sort. Function merge sort. When you pass the array to it, inside this I'm going to check if array dot length is less equal to 1. In that case I am going to return the array, which means it's already sorted, so I don't need to have a small array, so I don't need to do anything. Constant middle of that array will be math dot floor array length divided by 2. Perfect. Now the left of that is array slice 0 middle. Perfect. And then my right array will be a dot slice middle. Perfect. And I will return merge with calling merge sort for the left separately and merge sort for the right. Perfect. So that kind of gives me my merge sort algorithm right here. Now how do we use it? Let's use create a array to sort equal to, let's use the same array that we used before, which was 3 6 8 10 1 to 1. Perfect. And then I'll say console.log merge sort, pass the array to it, run it, should be the same number. Perfect. So you saw we used two different algorithms here, quicksort and merge sort, to do sorting for an array. Binary search is an efficient algorithm for finding an item from a sorted list of items. It works by repeatedly dividing in half the portion of the list that could contain the item until you have narrowed down the possible location to just one. So let's see how do we do this binary search in a sorted array. So first I'm going to call a function, create a function called as binary search, and I need an array and target. Perfect. I'm gonna say first let left equal to 0, then I'm gonna create the right, which is array dot length minus 1, while left is less than equal to right. I am going to say constant mid equal to math dot floor left plus right divided by 2. Perfect. So that gives me the midway. And now I'm going to say if array of mid is equal to target, then in this case I will return mid. Else if in second case is array of mid is less than target, then in this case I will say left equal to mid plus 1, so I'm increment by 1. Else I'm going to do the same thing for the right one, right equal to mid minus 1 because it's in the other direction. So there, so for top one will search in the left, mid minus plus 1 will search in the right half, and this will search in the left half. And then if it can't find it even after this, I will probably say return minus 1, which means the target was not found. Now let's run an example in this case. So it's pretty straightforward. Constant sorted array equal to, okay, 1 3 5, I mean I don't care, this is a sorted array, looks like it. Now I'm going to say constant target equal to, let's look for 5. Okay, and then I'm going to say console dot log and run my binary search to find in my sorted array the particular target. Run it, and it says 2, which is 0 1 2, so second location. I'll remove these previous ones, and there you go. So this is our implementation of binary search. Now finding the kth largest element in unsorted array can be efficiently done using various methods. One of the most common methods is using a mini heap, but we can also use the quick select algorithm, which is efficient in place and average O big O to the n time complexity solution. So let's look at the quick select algorithm implementation. So first I need a function to do the quick select is what we're going to use. It will have an array and will have left, right, and k. So these are the attributes that I will need. And I'll say if left equal to right, then in this case I have the solution, which is return array on the left. So that's my return type. Now if that is not true, I'm going to create a pivot index. Now the pivot index will call a function called as partition array left and right, and in here I'm going to say if k is equal to pivot index, some space here, I am going to, in this case I will return array of k. Else if in the second case I'll check k is less than pivot index, in this case I will recursively call the quick select and pass array left that I have pivot index -1, and I will pass k back. So this is what I'll do. Else if none of them is true, else then I will again do the same thing, but in this case I'm going to pass the array, and for the left I'll pass pivot index +1, and I'll pass right and k. That's what I'll do. So it give me the answer, either one of them. Next, let's write the partition function. Partition array left right, that's what we need. Perfect. I'm going to create a pivot which has array of right. Perfect. Next I'll create the pivot index which is left. Perfect. And then I'm going to go, it was there, for let I is equal to left, I is less than right, I plus plus. Perfect. Did I add an additional? Yes, I did. So for this for loop, I'm going to check inside here if array of I is less than or less than equal to pivot. If this is true, what I'm going to do is I'm going to take the array at the index I and array of pivot index and set it to array of pivot index array of I, and then I will increment my pivot index. Once that is done, for loop is done for, I am going to go ahead and take my array of pivot index and array with right index and set it to array of right comma array of pivot index, and after this return the pivot index in this particular case. Now let's write the function to find the kth largest in my array, and the k number is k is what we'll pass here because that's the kth element that we want to find. Kth largest index to find is array dot length minus k. That's good. And then I will return the quick select, and here I'll pass the array that is passed to me. I'll say the left index is 0, array dot length -1 is the right, and index to find is what I'll pass here. Now let's look at an example. In this particular case, I am okay. That would also work, but I think I lost it. Constant array equal to, let's create an array. In this case, I'll say 3, 2, 1, 5, 6, 4. That's good. And I'm going to say k equal to 2. I want to find the second largest. Constant kth largest is find kth array k. Okay, let's say console dot log. I want to display that kth largest element. Run this. Let's clear it out. Run again. So second largest in this particular case, the biggest large 6, and then second is 5th. So that's what it shows me here. And this is how you can do this using the quick select algorithm implementation to find the kth largest element in an unsorted array. Now in dynamic programming, the first thing that we want to look at is solving the knapsack problem. The knapsack problem is a classic optimization problem. Here we'll solve the 0-1 knapsack problem using dynamic programming in JavaScript. In the 0-1 knapsack problem, you are given a set of items, each with a weight and a value, and the knapsack with a maximum weight capacity. The goal is to determine the maximum total value of items that you can put in a knapsack without exceeding the weight capacity. So think of it as like you have a sack and you have to add a bunch of items, but make sure that you are in your capacity. That's what this problem is. So I'm going to go ahead and write this function called as knapsack, and inside this the arguments that I need is values, the weights, and the capacity of the knapsack. Now first I'm going to say create a constant n equal to where I'm going to get values dot length of all the values. Next I'm going to create a dp element where I am going to create an array n plus 1 dot fill. So based on whatever my previous n value that I got, I'm going to create an array of that size and fill it from 0 dot map to array capacity 1 fill 0. That's it. So I'm going to fill that up, and once I have that, I am going to go over for loop I is equal to n plus 1. Perfect. In this, and then again I'm going to create another one to go through the array that we have. Hate it when it doesn't do nested arrays. W equal to 0, W is less than equal to capacity, W plus plus. So this is based on capacity. Let's close this, and then here inside that, first I'm going to check if weights of I minus 1 is less than equal to W. That's my first check. That will give me an idea about the, so dp, I will do dp of I and W in this particular object. I'm gonna go ahead and do math dot max from dp of I minus 1 of W, comma dp of I minus 1 of W minus weights of I plus 1, and then finally after this I'm going to add values of I minus 1. That's perfect. What I'm going to do, if this doesn't work, if this is not true, I am going to go into the else loop and say dp of I of W is dp of I minus 1 W. So that will create my so give me my dp of n with capacity. So this will solve my knapsack issue. So let's run this and see if it actually works. So I have constant values of, let's say 60, 100, whatever it automatically gives me. I'm going to use that. Weights equal to 10, 20, and 30, and capacity of this knapsack Now if you see 30, 40, 50, 60, so I'm going to make it 50, a little less than the entire capacity, and then I'm going to say actually console.log, and inside this send my knapsack uh, with values, with weights and capacity. Let's run it. Syntax error, map. Let's see, I realized that I did something wrong over there because of okay, array of here, array of n plus 1 dot fill of 0 dot map. I'm missing a bracket, looks like. Oh, sorry, map function array, and then closing here. Run. Perfect. Run this. Let's clear it again and run this. It gives me an answer of not a number. It should have given me 220 based on this 100 and 120 value. Let's see, where did we, so we said knapsack values weight capacity n equal to values dot length, and then inside my dp n plus 1 I filled it with 0 and then got the map of that object array where capacity plus 1 and filled it with 0. Perfect. Let I equal to 1, I is less than equal to n, I plus plus, and w is less than capacity, w plus plus. If weights of I minus 1 is less than equal to w, then I said this was a little bit complex, so let's see, math of max dp of I minus 1 w and dp of I minus 1 w minus weights, I minus 1, not plus 1, that will go to the next one. So that is good, we saw that. Let's see, let's run it, and we get 220. Similarly, if I say that this value has only 40, so that means it will be 180 in this case, because it can do 30 and 10, which is 120 plus 60, so 180. Perfect. So this is how you can solve the knapsack problem using JavaScript. The longest common subsequence or LCS problem is another classic dynamic programming problem. Given two sequences, the task is to find the length of their longest common subsequence. A subsequence is a sequence that appears in the same relative order but not necessarily contiguous. So let's look at how we can solve it using JavaScript. First, I'm going to say function longest common subsequence. Okay, go to it automatic, and I take two strings inside, string 1 and string 2. Say constant m equal to, I'm going to take the first string and get its length, constant n equal to, take the second string and get its length. Now I'm going to say constant dp equal to array of, same thing that we did before, m of 1 plus 1 fill 0. Actually this is fill null in this case, and map it to array n plus 1 fill of 0. Okay, that's the checked. Next I'm going to write the for loop to go over, and then another for loop, let j equal to 1, j is less than n, j plus plus, so go through both of my constant m and n. And okay, it did write everything for me. If string 1 of is I minus 1 is equal to string 2 j minus 1, dp is I, this is 1 plus, okay, that's fine. Sometimes I used to increment from the end. dp of I minus 1, j minus 1, perfect. Else dp of ij math max, perfect. So this is our, it was right there, and again I'll probably have to write it now. So I'm going to say if string 1 of I minus 1 is equal to string 2 of j minus 1, in this case, if, okay, in this case I will have dp of I and j equal to 1 plus, perfect. Else I will have dp of I and j equal to math.max, and that's the one that I was looking for. And then once that is done, at the end I will return dp of m and n. So this will be my final answer output. So let's test it out. So let's say if I have a first string, let's say text1 equal to something like a b c d e, and then I have another text2 which is ace, let's say, since it wants me to enter ace, and then I can say console.log. I can say in this particular case longest. Okay, I'll pass those two, run it, and this should give me the answer 3, because the longest subsequence is 3 in this particular case. Longest common subsequence ACE is the longest common subsequence, which will give us the answer of 3. So that kind of solves our dynamic problem programming solution for the longest common subsequence. If you have any questions, let me know in the comments. Now let's look at the longest increasing subsequence. Now LIS problem is another classic dynamic programming problem. Given an array of integers, the task is to find the length of the longest subsequence such that all the elements of the subsequence are sorted in the increasing order. So that is important to remember. So let's see how we could implement in JavaScript. So I'm going to say a function length of LIS, longest increasing subsequence. It will get me an array, and what I'm going to do is I'll check if array dot length is equal to 0. If it's 0, I'm going to say return 0, because there's nothing in there. Always have to check for the worst case scenario. Then I'm going to say dp equal to array of this particular, I say array dot length, and I'll say fill this with 1 for now. Next, I'm going to run a for loop. Come on, fill it up. Nope, it doesn't like to. Let I equal to 1, I is less than array dot length, I plus plus in this case. So and I'll go over again with let j equal to 1. Oh, sorry, j equal to 0. Go first. J is less than I, j plus plus, and inside this I'm gonna check now if array of I is greater than array of j, then I'll set the dp of I is mat.max dp of I, comma dp of j plus 1. Perfect. So that is the complete logic here. That's all that you have to do. Return math dot max now out of the entire dp array. So I'm going to spread it out the array and then give me the output instead of writing multiple lines in this particular case. I'm going to create a numbers array and call it, let's say, this one, whatever it gives me. And then I'm going to say, you can just say console.log. In this particular case, I'm going to give me length of LIS based on the numbers that I have. Give me the longest increasing subsequence in this case, and in this particular case, based on what we see here, our longest subsequence will be 4, output 4, because yep, run, and the output is 4. So that's how you can solve the longest increasing subsequence in using JavaScript. The n queens problem involves placing n chess queens on an n by n chessboard so that no two queens threaten each other. This means that no two queens can be in the same row, column, or diagonal, because that's how they move. Let's go through a backtracking solution to solve the n queens problem in JavaScript. So I'm going to go ahead and first create a function called as solve n queens. That's what I'm going to call it, and I'll pass the variable n. And now here constant results, I'll create an array for that. Next, I'll create the board, which will be board of new array n, and then fill it with nothing map of 0 array of n, fill them by. Okay, this is perfect. So this, once we have done this, let's create a function to check if is safe, where we have the board, the row and column. Okay, so once we have this, now let's check for column. For let I equal to 0, I is less than row I plus plus. Since we are looking for the column, that's what I'm going to do. And I'll check here if board of I of column equal to not this, but I'll probably say Q, then I'll say return false. Next, let's check for the upper left diagonal. So for let I equal to row, j in this case will also have j equal to column, I is greater than equal to and j is greater than equal to 0, I minus minus, j minus minus. Perfect. So in this will check for our upper left diagonal. So if board in this case I and j equal to Q, then I'll say return false. So this is good. Next, we should look for the upper right diagonal. For let I equal to I row, j equal to column, I is greater than 0, less than I is less than, in this case n, or n, sorry, think small n, I minus minus and j plus plus in the other direction. So this will give us, if in this case board of I of j in this case equal to Q, screen is present, I'll say return false. If none of these work, then that means return is safe. So return true in that case. So we're not safe in any of diagonal or row or column wise, but other than that, it's fine. So we have that. So next, what we're going to do is we're going to do a function for solve. We call a function called as solve and pass it board and row. And in this case, I am going to check if row equal to n, then in this case I will have constant, I'll create a copy which will be board not dot map but dot copy, sorry, it was map board. I'm creating a copy of board dot map row, and in this case I'll say, instead of this, I'll say row dot join by empty spaces. Perfect. Oop. Nope, wrong location. Okay, there you go, that's good. Results dot push copy, and then I'll return that. Next, let's write a for loop to solve this. So let's go through the entire thing. I'm going to say let column equal to 0, column is less than n, and column plus plus. So going through this loop, I'm going to check first if is safe board row column, then board row column equal to Q, solve board row plus 1, and then board row column equal to 0. Perfect. So that will be our backtracking. Now let's go outside and call the function solve for board and 0 and return the results. Perfect. So let's look at a sample usage of this. So this is what we'll be solving. So in this case, we're checking if the queen is safe. If it's safe, then it's true. Then for the solve, we go through the board and look for the combinations and return the results at the end. So let's look for n equal to, let's say, 4, and let's say constant, let's say whatever number of solutions we have, I'm going to pass that, and then I can say console.log solutions dot, let's do length. I don't want to see the solutions, but I want to see the length. So now if I want to go through each and every solutions here, I can say solutions dot for each of them solution index, and create a function here. So for each of them, each of the solution that I have, I will console.log saying, let's give it a nicer pattern. Solution is, let's use the pattern. In this, I'll say dollar index +1, close this, and below it I'll say solution dot for each row console.log row, perfect, and I'll say console dot log and print empty out there, just so that it goes through that and displays me my solution. Let's run this and check. So there you go. Let's use, instead of 0, let's use dot. I guess this will cause a problem in my, so yeah, of course this is, since I'm using dots, and I think I filled up in this place 0 or here row equal to, so it looks prettier. Run. Let's clear it out and run it again. So as you can see, this is the solution 1 for two different for the n equal to 4, where these are the combinations that are available, where the queens, 2 queens are safe for n. So for n queens, these are different combinations which is safe for the queen. So this is our solution for the n queens problem. Go through it. If you have any questions, let me know in the comments. Generating all subset, also known as power set of a set, is common problem that can be solved using various approaches. One of the simplest and most intuitive ways is to use backtracking. Now another common approach is to use bit manipulation, but let's look at a solution using backtracking first. So I'm going to write a function, call it subsets, and pass it numbers, and inside this I'm going to create a result array, and also I'll create another subset array, since we want to generate all the subsets of a set. So these are two different things that we need. I'm going to create a function backtrack with start as the parameter, results dot push. Inside this I'll push the spread out version of subset in an array. Next I am gonna say for let I equal to start, I is less than nums dot length, I plus plus. For each of them, what I'm gonna do is I'm gonna say subset dot push, and inside that I will push the nums of at index I. Then I'm gonna backtrack again, call the backtrack recursively with I plus 1. Then I'm going to say subset and pop the value, the last value that I insert. That should give me the backtrack object, and now I'll call the backtrack with 0 and return the result. So this is the easiest way to get this up and running. We can look at an example usage of by creating a nums array of, let's say, 1, 2, and 3, and then I can say constant all subsets of this is equal to subsets of nums. Oops, had that right there, nums, and then I'll console.log to look at all these subsets, but I can say all subsets, and below here I can just say all subsets dot for each item in there, for each subset there is there, I want to console.log subset. So this will show me all the different subsets available. So there you go, an empty array 1, 1, 2, 1, 2, 3, 1, 3, 2, 2, 3, and 3. So these are different subsets available. So this is an easier way to generate all the subsets using backtracking. Solving a Sudoku puzzle is a classic problem that can be tackled using backtracking. The goal is to fill a 9 by 9 grid so that each row, each column, and each of the 9 3 by 3 subgrids contains all the digits from 1 to 9 exactly once. If you don't know what Sudoku is, I would probably recommend you to play a game or two and then come back and look at this particular solution. So let's see how we can solve a Sudoku using JavaScript. So I'm going to create function solve Sudoku, and I'll pass it the board, and inside the board I'm going to say if solve board. It's another function that I'm going to write, which is not solve Sudoku but solve. I am going to say return board, else I am going to say return no solutions exist, because sometimes you don't have enough number of numbers to make the entire board work, which is sometimes also multiple solutions, or something is messed up with the question. So let's look at that solve function. So I'm going to use that solve function, and inside that solve I'm going to write a for loop. Let row equal to 0, row is less than 9, because it's 0 to 9, row plus plus, that is for the row. Now next column, for let column equal to 0, column is less than 9, column plus plus. Perfect. So that takes my row and column. Now in this particular case I'm going to check if the board of row of column is equal to, in this case let's use the empty because it looks nicer, as we saw from the n queens problem. And I'm going to go over for let number equal to 1. So I'm going to go over all the numbers. Number is less than equal to 9, num plus plus. I'm going to go through each and every number and check if valid. So I'm going to say if is valid. So if is valid, board row column num, then I will say board row. So instead of writing the logic here, I'm just going to call the is valid function, which I'm going to run in a little while. So I'm going to say row and column is equal to number dot toString. Next I'm going to say if it's possible to solve the board here, I am going to say return true. If not, I'm going to go ahead and say board of row column row and column equal to dot. Perfect. Next let's go ahead and two of these, and then here return false, because here is trigger backtracking. So this is where we trigger the backtracking part. This is where we backtrack, and this is we trigger backtrack. And if everything works fine, I'm going to go here and say return true, which means all the cells are filled in this particular case. Next, now we're going to look at the function is valid, which I have called above but have not created it. So is valid, what happens is you pass the board row column and the number that you want to check, and in there I am going to first say number string, create an object, say number dot toString, and for let x equal to 0, x is less than 9, x plus plus. What I'm going to do inside here is I'm going to check if board of row x is equal to that number of string. If it is, then I'm going to say return false. Okay, that's perfect. And next I'm going to check the column. So this was the check for the row. Next I'm going to check for the column. I'm going to do the same thing for y is equal to y is less than y plus plus. I am going to say if board of column is, so board of y of column is equal to number string, I'm going to say again same thing, return false. So this is not a valid number. Next I'm going to check the 3 by 3 box. So for that I'll here after this for loop I'm going to say constant start row is equal to mat.floor row divided by 3 times 3, perfect. Constant, I'm going to create the start column, which is again mat.column, perfect. And next I'm going to run the for loop on it for let I equal to in this case 0, I is less than 3, I plus plus. I am going to go inside the j for let j equal to 0, j is less than 3, j plus plus. So go through that 3 by 3 row and check if board of start row plus I in this case, and then start column of j, start column plus j equal to num string. If that is there, then again not valid, so I'm going to say return false. And if all of these conditions are not met, then that means it's valid, so I'm going to pass back return true. Now let's create a board. Okay, it's going to take some time to put together the board unless this thing helps me with the board. Let's see. This is a double matrix of board. Okay, so it's not going to give me a board. Give me a second, I'll get the board and paste it here. So here is my board, 3 by 3, 3 by 3, 3 by 3. Just make sure that it's properly ordered. And now once I have my board, I'm going to say constant solved board equal to solve Sudoku and pass the board to it. Let's see if it works. Console.log. I'm gonna make sure that it looks good. So Sudoku, solve Sudoku, and solve board dot for each of these elements. I am going to say row console dot log row dot join. I'm gonna give it space here. Perfect. Hope I have all of them. Let's run it. And there you go. That's a solved board. 4, 3, 4. If you just look at the first 3 parameters, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. So you have all, this is the solved board. So this is how you can play this. You can use some samples online and put different boards, or if you have a Sudoku game at home, you can always try to solve this using this particular function. So I hope this helps. For bit manipulation, we have 3 different problems that we're going to look at. First one is the count the number of set bits in an integer. Then we're going to look at the find the single non-repeated element in an array where every other element appears twice. And then we're going to look at swap 2 numbers without using a temporary variable. So to start with, let's look at the count the number of set bits in an integer. Now counting the number of set bits or 1 bits in an integer is common problem that can be efficiently solved using bit manipulation techniques. Now let's look at a solution here. What I'm going to do in this particular case is write a function, call it count set bits, and inside here, so let's start with count equal to 0. Now while n is greater than 0, if the number is greater than 0, count plus equal to n and 1. And 1. So this is an AND operator which will probably give us the value for increment the count if there is 1. And then I'm going to do the logical operation of moving that by 1 using this particular operation. Now if you don't know these bit manipulation operations in JavaScript, it's a good place to look at. And then that will give me the total number of 1 or set bits in this particular code. So it's pretty straightforward. Let's use a number number of, let's see what does it give me. Nothing. 20, let's say 29. 29's binary representation is, I can always say binary representation of 29. So this is the binary representation, and that's what we are looking for. So we have 1, 2, 3, 4 set bits. I'm going to say constant, or we can just go ahead and say console.log count set bits for my number and run this. It says 4 here. Let's try another number. Let's say 56 has 3 numbers. So let's say 56, run, and we have 3. So take a bigger number, 4574. Oh, too big. Let's use 45, where we have 4 again. Run, and there is 4 over here. You can give a bigger number. Run, it will give me the bits, but then the thing is, what is the binary representation of this? Probably will 4045. If you see here, this is the representation. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's the solution that we go. So this is how you can counting the number of set bits in an integer. Next, let's look at the find the single non-repeated elements in an array where every other element appears twice. So in this particular case, this can be solved using the XOR operation, where XOR has a property where A XOR A is equal to 0 and A XOR 0 equal to A. Therefore, when we XOR all the elements in the array, the pairs will cancel out, leaving the single non-repeated element. So let's see how that can be implemented in JavaScript. I'm going to say find single non-repeated element and pass the array in there, and inside here I'm going to say let result equal to 0, start with 0, and now for, let's say, constant number of array, what I'm going to do is I am going to XOR that by using the XOR symbol, which is the caret symbol, equal to num. That's it. Return the result. So let's try this using a constant array equal to, in this particular case, I'll say 2, 3, 5, what is it trying to give me? 4, 5, whatever it is. Okay. So in this case, okay, let me use a sample that makes more sense. 2, 3. So let's try this out. Constant array equal to 2, 3, 5, 4. Just randomly picking up numbers, 5, 3, and 4. So in this case, single non-repeated elements are 2. If you look at it properly, 2, 1 for this and 1 for this. So that's what we are expecting as the output. So constant, or we can just do console.log, and in this case I can just say just call the method and pass the array to it. Clear out the console, run it, and it should give me the output 2, and there you go, that's the output over there. Next, let's look at swapping two numbers without using a temporary variable. So now this can be achieved using arithmetic operation or bitwise XOR operation. Let's run that and see how we can create that. So let's say function swap a and b, and inside here I can just say console dot log. I don't want to say before and after. Let's just a equal to a plus b, b equal to a minus b, and then a equal to a minus b. So this is just by using simple arithmetic operations where we will have numbers. So here I'm going to say console dot log a comma b, uh, a, let me just say a plus empty plus b. So it kind of shows me this value before. Oops, I think I pressed on by mistake. And then let's say let's swap it. Swap 5 and 10. Let's run it. So 5 and 10 and became 10 and 5. So what I'm doing here is like a equal to a plus 5. Then for b I am removing that much from b, and then a I am subtracting again with b. So that kind of gives me swap operation using arithmetic operation without using another number. Now if I want to do this with XOR operation, I can just say function swap XOR. If I'm using XOR, I can say AB, not function. When you work with different programming languages, that's what happens. I'm going to say same thing here, console A and B, again console A and B, and do the XOR operation equal to A XOR B, and then B equal to A XOR B, and A equal to A XOR B. So if you see, the operations are exactly same because XOR just cancels out the thing and gives you the solution. So I'm going to say swap 2 and 4, 2 and 5, swap XOR. That's the function that I wanted to call. Let's clear this and run this. And you see 5, 10, 10, 5, 2, 5, 5, 2. So this is how you can do swap with the arithmetic operation as well as XOR operations. If you have any questions on bitwise manipulation, let me know in the comments. For hashing, the most known questions are about finding the first non-repeating character in a string. So next is the check if two strings are anagrams, and the last one is two-sum problem. So first, to finding the first non-repeating character in a string can be done efficiently by using a hash map to count the occurrence of each character and then iterating through the string to find the first character with a count of 1. So let's go through that. Let's create a function in JavaScript and see how we can solve it. Function find non or we can just say function first non-repeating character, and that gives me a string, and I'll say constant character count equal to new map, and now first count the occurrence of each character. That we can do by saying for let character of string. What I want to do here is I'll say character count, the one that we have declared above, dot set character comma character count dot get character or 0 plus 1. So that's our entire logic for this, to count the occurrence of each character. Next, let's find the first character with a count of 1. So I'm going to say for let character of str, and here I'm going to say if character count dot get char equal to 1. In that case, I'm going to say return character. That's the one, the first non-repeating character in a particular string. That's what I find. And then if not, I'm going to return null, because which means there's no non-repeating characters found. So to run this, let's create a constant string equal to, let's say, Swiss. because it has a lot of s in there, and I am going to say console dot log first non-repeating character and pass the string to it function. Run it. It'll give me w because w is the first, I is the next one. If I remove this sys, it'll say I in this case. So that's our solution for finding the first non-repeating character in a string, and this is how you do it. Check if two strings are anagrams. So you're given two strings and you have to figure out if they're anagram. Now anagram involves verifying that they contain the same characters with the same frequency. Let's see how we can do that. So function are anagrams, where I pass two strings, string 1 and string 2, and I'm going to say if string 1 dot length is not equal to string 2 dot length, which means it can be anagram because they don't have the same number of strings to start with, turn false. And then if they are not, then if they are same length, that means the first test is passed. So I'm going to create a new map here, character count map, and then I'm going to go count the frequency of each characters in string 1. So I'm going to say for let's say character of string 1, for that I'm going to say character count dot set character comma character count get char 0 plus 1. So that's same as the previous code that we added. It's much similar. Next, we'll decrease the frequency based on the characters in string 2. So here I'm going to say for let character in string 2, I'm going to say if not character count has character, so I'm going to say return false, which means the character is not found in string 1 if it's not there. If it's there, I'm going to just say character count dot set character comma character count dot get character minus 1. So this should, let's see if I don't need this bracket here, count minus 1. So I reduce that number, and once I'm done with that, I can just say character count dot get character equal to 0. So if it's 0 now, then we will go ahead character count dot delete that particular character. I don't need that character anymore because they have cancelled out each other. And then after my if loop and this loop, I can just say return character count dot size equal to, if it's equal to 0, then it's true. If it's not, then if character, so in this case what I'm doing is if character count is empty, the strings are anagrams. That's what I can do. So let's start with an anagram constant, not console const, or I can just say console.log, and I can use the r anagrams function and pass listen and silent. If you see the same number of strings and as is an anagram, it says true. If I remove something, run it, says false because first of all the length is not fine, but if I add this anywhere else, it will be true because that's the same number of characters and is the same character, same number of characters in the same amount of size. So that's how we can do check if two strings are anagram or not in JavaScript. So the two-sum problem involves finding two numbers in an array that add up to a specific target sum. Let's look at how to do that. So if I say function two sums and I have an array of numbers and my target number, the total number that I want, in here I'm going to say constant num map equal to create a map of that. Next I am going to go write a for loop to go to the array, and then inside this first thing I'll do is I'll find a complement equal to target minus nums. Now if this num map dot has the complement, so I'm doing subtracting, which kind of gives me the target number or the rest of the sum for the target number. So that will give me num map complement I. Or else I can say num map dot set nums of I comma I, and then go through the next iteration. If nothing works, then I'm going to say return null, which means there's no solution found for this particular two-sum problem. So let's see an example. Constant create a, I can just say console.log and call the two sums function, and inside this I'm going to give an array of let's say 2, 7, 11, 15, and then my target in this case is 9. So if you look at it, 7 plus 2 is 9. So it will say 0 and 1 are the elements which are there. Now if I want to do 15, 17, so 15 plus 2, which is 0, and the element at third, 0th element and third element are 15 plus 2, which is 17. So that's how you can do your two-sum problem. If I do 134, it should say null, because 134, no two numbers can add to that. So this kind of concludes our hashing with all the three different questions that are commonly used. Implementing a queue using two stacks is a classic problem that involves using the properties of stacks to simulate the behavior of a queue. Let's see how we can implement it in JavaScript. So we're going to implement, in this particular, we're going to implement queue using two stacks. So we will use two stacks, in this case stack 1 and stack 2. Stack 1 is used for enqueuing operations and stack 2 is used for dequeuing operations. The main idea is to transfer elements from transfer stack 1 to stack 2 when we need to dequeue, ensuring the queue order is maintained. So let's go ahead. I'm going to create a class called as queue using two stacks, and then in my constructor, since I don't have to pass anything here, I'm going to create my this dot stack 1 equal to an empty array. So this is my first stack and this is my second stack. So I have two stacks ready. Now let's write the enqueue function. Enqueue value, where this dot stack 1 push the value to stack 1, as I mentioned. Next, let's write the dequeue value, dequeue function. In dequeue, what I'm going to check is if this dot stack 2 dot length equal to 0, which means there's nothing in stack 2, while run the while loop here, and inside this I'm going to say this dot stack 1 dot length is greater than 0, misspelled, length is greater than 0. As long as it's greater than 0, what I'm going to do is I'm going to say this dot stack 2 dot push, what do I want to push inside? This dot stack 1 dot pop from there, and whatever is popped I push it inside stack 2. That's how you dequeue. Now another thing that you have to check here is if this dot stack 2 dot length is equal to, again let's check, equal to 0. So what in this particular case what it means is the queue is empty. So I'm going to say, so even after doing this, if this is length is equal to 0, I'm going to say throw new error, queue is empty. Next I am going to return from this function, I'm going to return this dot stack 2 dot pop. So that's my dequeue function. Next let's peek, let's write a function called as peek to peek inside the particular stacks. So I'm saying if in this case, again, if the stack2 dot length equal to 0 and stack1 dot length is greater than 0, I'm going to do something similar here too, and then I'm going to queue is empty, and from this function I'm going to return this dot stack2, this dot stackdone minus 1. So that's what I will return. Make sure it's properly formatted. So that's what my peak function does. Next, let's also do is empty. Check if it's empty. So that for that function, I am going to just say return this dot stack1 dot length equal to 0 and stack2 dot length. Okay, so if this is, that means it's empty. Let's see an example usage. So this is a complete enqueue, dequeue, and queue using two stacks functionality. Now let's create a queue first. Queue using two stacks. I'm going to enter something in the queue dot enqueue. Come on, do it. And enqueue 1, queue 2, enqueue 3, and queue 4. We'll also go here and do console.log dequeue, so I can see the output of 1 in this case because the first item is added here. So I'm gonna do that. I'm gonna do again here dequeue. I am going to do a queue of peak here just to look at the value in this. I am going to also say check if it's empty. I am gonna go ahead and dequeue again. So this time I will get the value of 3. This will give me the value of 4. And here I'm going to check if it's empty because we've removed everything from there. So let's run it and see. So first enqueues 1. So this is the first dequeue, so it removes 1, then removes 2. Then when I peek here, I get 3. 3 is the value on the top, is false. Again, I'm removing 3 now. 4 removed and is empty is true in this particular case. So this is how you can implement a queue using two stacks using JavaScript. Evaluating a postfix expression, also known as reverse Polish notation (RPN), involves using a stack to keep track of operands and apply operators as they appear in the expression. So let's look at how we can write the solution using a stack. So I'm going to start with the function, and this function I'm going to call it evaluate postfix, and expression is I'm going to pass to this, create a stack uh, which is an array in JavaScript, constant, then operators equal to new set. Let's say which all do we support. So new set with plus, minus, multiply, divide. Next I'm going to write a for loop where I'm going to say, not this one, constant token of expression. I don't want split. I'm going to go through each and every expression in this case and say if operators has token, if my operators has that token, I'm going to say stack dot push token. Actually I'll use the, if the token is a number, then we'll push it to the stack. So I'm going to say number token. There you go. Else what I'm going to do is I'm going to say if the token is an operator, pop 2 elements from the stack. So in that case I'm going to say constant b equal to stack dot pop and constant a equal to stack dot pop again. Then we will apply the operator and push the result back to the stack. So I'm going to say switch based on what token it is. If the token is let's say plus, then in this case I'm going to say stack dot push a plus b break. If so, I'm going to just copy paste this a bunch of times because we're going to do it for plus, minus, multiply and divide. Minus, multiply, and the last one is division. Okay, so that's what we will do. That kind of takes care of that function, and then I'll return once everything is done. I can just stack dot pop. Pop. So let's try with an example. In this particular case, I am going to create a constant expression equal to, I'll give an array of 1, 2 plus, okay, that works for me. And then I'm going to say, or just console dot log, in this case evaluate expression, and I'll pass the expression to it. Let's run this. Oop, somewhere I missed stack. Okay, let's run this. No errors, and this gives me the output as 9. If you look at it, 1, 2 plus 3 multiply. So I'm saying that add 1 and 2, uh, and that is 3, and then 3 times 3 is 9. So that's the output we get in this particular case. So that's how you can uh, you can you can evaluate a postfix expression using JavaScript, and this is the logic that you'll be using. Another question that is mostly asked is design a stack that supports push, pop, and retrieving the minimum element in constant time. Now, doing this, we can kind of efficiently achieve this by using two stacks. One to store the actual stack elements, and another to store the minimum elements. Let's see how we can implement this. So I'm going to create a class in this particular class, in this particular case, call it minStack, and inside this I'll create the constructor, and this constructor will have this dot stack is empty, and I'm going to call it minStack. Next I'm going to push the value function, write the push value function, this dot stack dot push the value. Then I'm going to check if this dot minStack dot length equal to 0, value is less than this dot minStack this minStack length minus 1. I hope that is length. Okay, minus, that is what was missing, minus 1, and then close this. And if this is true, that the minStack dot length equal to 0 is like, so in this case I'm just gonna push the value. I'm going to say this dot minStack dot push value. Next function that we have to write is for the pop. So for pop, I am going to say first check if this dot stack dot length equal to 0. Let me just check this. If the stack dot length equal to 0, I'm going to not return, but I'm going to say throw new error, stack is empty. Else, and next what I'm going to do is I'm going to check for the popped, this dot stack dot pop. I'm going to pop that value. If popped equal to this dot or if the, yeah, this dot minStack dot length minus 1, then this minStack pop, and return that popped value. Perfect. So this is our pop. Next, to get the top value, in this particular case I'm going to say if dot, okay, there you go, if dot this dot stack dot length equal to 0, throw new stack is empty, else return the top of the stack. Perfect. Next is the get minimum function. Let's move it up a little bit so it's clear. In this minimum function, what I'm going to do is I'm going to check if this dot minStack dot length equal to 0, empty, return this dot minStack dot length minus 1. That's what will pass. Perfect. So that is the get minimum. So this is how you can implement the push, pop, and tap using two stacks. Let's run it. and give an example and see if it actually works. So I'm going to create a min stack. Next, I'm going to add some value to it. Okay, give me one more. Min stack push, then I'll push 0, then I'll push one more, let's say push -3. I'm going to do a console log of console log. In this particular case, I want to check the minimum item, so I'm going to run this, which is -3 according to this. I'm going to min stack dot pop, so this will pop the element. And now if I say console dot log, I want to check for the min stack dot top, so it should be 0 because the top value is 0, and I can also say get minimum. This time it will be -2 because -3 is already popped. So let's run it and see if it works. So I have -3 for this one, which is get minimum out of the 3. Then I am saying pop, I'm saying min stack dot top is 0, that's on the top, and then min stack dot get minimum is out of the 2 is -2. So this is how you can solve or design a stack that supports push, pop, and retrieving the minimum element in constant time. Moving on to mathematical problems, first thing that will look is very common is check if a number is prime. Now, checking if number is prime can be done efficiently by testing for divisibility up to the square root of the number. Hence, here's an implementation of how we can do it. So first, we'll start with a function which we'll call is prime, and whatever the number that is passed to us, inside this, I'm going to check if n is less than equal to 1 or less than 2, which was the previous one. Then I'll say return false. Why? Because 0 and 1 are not prime numbers. So this is the check for that. If n, next check that we do is if n is less than equal to 3, then I'll say return true. Why? Because 2 and 3 are prime numbers. Make sure that this looks cleaner. So this is because 2 and 3 are prime numbers. Now next I'm going to say if n mod 2 equal to 0 and n mod 3 equal to 0, return false. Why? Because multiples of 2 and 3 are not prime numbers. So this will return false. Now for the rest of the numbers, I'll say for let I equal to 5, I times I is less than equal to n, and I plus equal to 6, not plus 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 plus. So I'm incrementing by 5 by 6 numbers for every time. If in this case n mod I equal to 0, or another operation is n mod I plus 2 equal to 0. So either of the case, in this case the number is not prime, so I'm going to return false. If any of these combinations don't work, I'm going to say return true. Now let's look at an example usage for this particular case. I'm going to say constant number, or I can just go for console.log and check is prime 1, which is false because 1 and 0 are not prime numbers. I'm going to give a number that is 28, which can be divisible by 2, so it will say false. But what about 29? 29 I'm sure is a prime number. Run it and it says true. So this is how you can create a function in JavaScript which will tell you if a number is prime or not. One of the common algorithms that probably we have learned in school is the Sieve of Eratosthenes, and this one helps you generate prime numbers. Now, if you don't know what this is or never heard about it before, you can always Google it, and Wikipedia will show you what it does. What it does is it iteratively marking as composite, not prime, the multiples of each prime starting with the first prime number 2. The multiples of given prime are generated as a sequence of the numbers. So this is the matrix that goes through it and iteratively looks for prime numbers and gets you that. So it has the algorithm and everything in here, but I'm going to do this in JavaScript so you can see how to implement this. So I'm going to say function is this, and I will pass the limit of how far do I want to go. And in this case, I'm going to say constant prime number primes equal to create an array limit +1 fill true. Then I'm going to create primes of 0 equal to primes of 1 equal to false. This is 0 and 1 are not prime numbers, so that's what I'm removing. Next, I'm going to write a for loop where I equal to 2, I is less than equal to, in this case, not square root, but limit I plus plus. In this case, I'm going to say if primes of I, the array that I've created, if there's a value in there, I'm going to say if it's true for let j equal to j is less than equal to limit j plus equal to 1 prime equal to false. This case, and then this will go through all the numbers and give me the primes. So to return this back, let's say return primes dot map is prime index is prime or index or null. So depending if it's prime, will give you index or null, and then I'll filter through it, and depending on the number is not equal to null, that's what I'll pass back. So this will give me if a particular number is prime or no. So what I'm going to do now next is let's use this algorithm. So if this is pretty straightforward to implement this, I'm going to create a prime numbers and give limit of 100, and console.log I'll give say prime numbers, run it. So it gives me an array up till 100, all the prime numbers 2, 3, 5, 7, 11, 13, 17 looks good to me, and these are the prime numbers up to 100. I don't know how further high up can JavaScript go, but if I say let's say 10,000, it'll give me all the items pretty quickly. But if you go to a higher number, as you know, the highest prime number currently is pretty big, but I'm not sure if JavaScript will support it. But this is how you can generate prime numbers using the Sieve of Eratosthenes. In the last mathematical problem that we'll look at is find the greatest common divisor of two numbers. So that's finding the greatest common divisor, GCD, of two numbers can be efficiently done using the Euclidean algorithm. The Euclidean algorithm is based on the principle that GCD of two numbers also divides their difference. So that's the algorithm. So let's see how we can implement that. We create a function, call it GCD, pass the values a and b, and here I'm going to say while b is not equal to 0, while b is not equal to 0, I'm going to create a temp equal to b, put b inside there, and then I'll do b is equal to a mod b, and a I'll put it in temp. Temp I'll put it in a. So that's my while loop, and that will give me the value. This is the Euclidean, pretty much Euclidean algorithm right here. Return a. Now if you want to test it out, let's see console.log GCD of 12 and 18. As per this, it's going to be 6 because 6 times 2 is 12, 6 times 3 is 18. Run it, and there you go. That's your answer. If I want to use some other numbers, let's say 40, let's change this to 48 and 18 and run it. In this case, it's 6 again because of course 18 is 16 3 times. 24, let's see if it's a bigger number. 24, because 24 times 2 is 48. So that's, if I say 12 here, it will be 12 because 12 times 4 is 48. So that's how you can solve the greatest common divisor of two numbers using the Euclidean algorithm, which says that the principle behind this is uh, the GCD of two numbers also divides their difference. So that's why we get this.